Greetings everyone. We're going to pick up with an in-depth discussion of state machines today. So we've talked a little bit about state machines, but now we're going to discuss them in more detail. Okay, so kind of our objectives as we think about what state machines are is to be able to describe when we're going to want to use them, how we would come up with situations to navigate different states, and finally how do we implement them in firmware. Okay, that's kind of our goal. What is the main point? Like, what's the whole reason that we're doing this, right? The goal is that our devices should be able to operate remotely, right, without us. That's the, oops, pardon me. That's the whole point. The point is that we want to be able to operate our devices remotely. And that means they need to respond to input from the world. They need to know what states they're in, right? If you think about your reaction timer, there could be, you're waiting for the buttons to be pressed, and then you're listening for someone to push a button. And then when you're in a different state, you produce different outputs. Maybe the light blinks, maybe there's other light blinks, okay? Tracking all of these, having the logic as you found, can be really complicated. And so, to solve this problem and make it easier for us to write complicated devices that can work on their own, we use the state machine. Here's the thing, a state machine is simply a model. It is a way that we think about our code and our device. Okay, so it's not like building an object in code or something like that. It's just kind of a general way of thinking about it. And so what we do is we want to know what has previously happened, what is happening right now, and from there we will generate what should be the new output and where should I go in terms of what's the next state or operation I should be in. Right? So it's kind of like you have this box, and your inputs in kind of a general way, your inputs are your state, your current state, and then your whatever input, maybe the user pushes a button, right? And the outputs are going to be your next state and your outputs, which maybe the lights are turning on, okay? And this is your state machine. Okay. So let's look at a quick example. I have two examples I want to show you. So the first one is the stoplight. So if you think about a really simple stoplight, not a big intersection, just a simple stoplight, it's going to change after a fixed amount of time. So it goes to the different lights, right? So question, I'll give you just 5 seconds to think about this. What are the different states and how do you go to a different state? Well, this is the very simple diagram, right? If you are in green, you go to yellow. If you're in yellow, you go to red. If you're in red, you go to green, and so on. And what is this? This is maybe, I don't know, 30 seconds? Let's just say this is 30 seconds. So after, probably this one, you probably red to yellow. It seems a little bit faster. Maybe it's like 10. I don't know. Just kind of making this up. Okay? That's a state machine, a state diagram. So these are the states, red, green, yellow. And then you have the arrows represent the state transitions. If you want to look at this in a table form, here's a different way of looking at it, right? Here's the state. The state would be traffic is flowing. And the output is going to be the green light. Traffic is stopping. That's my state. I'm going to be in yellow. Traffic is stopped. I'm going to have the red light out. So it's a really simple state diagram, right? So you've got the diagram and the table. Now, you might be asking really quickly saying, what would I do with this? Okay, so basically what we're going to do is once we figure out what the state transitions are supposed to be, we're going to write some if statements and some switches and probably some enumerations, and that's how we control the logic. Okay, so that's sort of the point of why we're doing this, in case you're confused. Let's look at another example, a much tastier example. So, right, the Sprinkles cupcake machine, it's basically an ATM, but it dispenses delicious cupcakes. And so ponder this for just a second. Maybe you've seen it, maybe you've used it, you can imagine a vending machine. Think about what are the different states that the cupcake machine can have, and how do we go from one state to another? Okay, so these are just some examples I came up with, but let's kind of look at this. So imagine that the machine is just sitting there, okay? It's idling. It's in the idle state. Now, there is no input. No one pushes any button, so it stays in the idle state, right? Now, Maybe another example would be we're in the idle state and someone pushes start. Well, now we display the menu. So we display the choices. Right? I won't go through all of these, but you can kind of get the idea that if you're displaying choices, if the choice that user wants is available, then let's go to the next state, which is process credit card. If the choice is unavailable, then we go back to displaying the choices. If they cancel, we go back to idling the process credit card. And finally, if we're in the process credit card state, if the card is valid, then we dispense the cupcake. So this is just a really basic vending machine example, but I want you to kind of see how there are different states, right? And based on the state that we are in, an input can trigger us to go to the next state. And for example, here in process credit card, if the input is valid, we dispense the cupcake. If it's invalid, we stay in process credit card. So this is how a state transition diagram can help you. Okay, now that's nice and lofty, but how do we actually implement this in firmware? Well, what we need to do is we need to worry about the outputs, the inputs, the states that we want to be in, and what is the logic that says when I go from one state to another. So, how do we solve each of these four pieces? Just like this. So our inputs, right, these are the inputs to the system. It's going to be what we already know, millis. So if you have something that's supposed to change states based on a timer, boom, you're going to use millis. If you want something to change state based on a button press, you can use digital read. If you want something to change based on a potentiometer or something, you use analog read. Okay, what are our outputs? Well, our outputs are everything we've used in class so far that produces an output. There's an LED, there's a speaker, your OLED screen, even serial monitor could count as this, right? Okay, how do we track states? Well, that's actually the easier part. We just simply create an enum and build the states that we want to create. And then we manage them that way. And then the part that's probably the trickiest part is you figure out what is my logic that says when I go from state A to state B, or from state A to state C, etc. Now, this is actually something we've already done before. I'm just formalizing a little bit. And really what we're going to be using is a switch statement. A switch statement, maybe an if statement, etc. And that's going to determine what the net states will be. So let me show you a simple example, pulling this together. Let's imagine that this is just one piece of the Sprinkles cupcake machine. Okay. I'm in the process credit card state. I'm going to get an input. That input is going to make me dispense the cupcake, or it's going to make me stay in my loop of processing the credit card. So based on this one simple input, I determine whether I'm going to be in the process state or the dispensing state. Okay, so let's think about these four pieces, right? If we go back to this slide, we've got these four elements: output, input, state, and state transition. How do we build these? All right, so our inputs are basically going to be, is the credit card valid or invalid? And that would just be a variable that we would define, card valid. Okay. Now somewhere in your code, you're going to, your device would communicate with the internet, with the Sprinkles headquarters, determine if the card was valid, etc. And that's how it would get a value. Okay. The next thing is, what state are we in? Well, we know to build a state, we simply say enum state. And then here we just list all of the values that possibly could be in the state. So if we look down here, we've got idle, display, process, dispense. So those are the states. And if we look back here, we see that those are basically the states we just described: idle, display, process, and dispense. Okay, those are our states. Okay, so this, we then build a variable called state, current state. So that's part two. If this is 1, this is 2, right? So here's 1, and here's 2. Okay. Now, how do we determine the logic, the state transition? That's an important part. Well, we simply have a switch statement. We say switch current state. So remember, current state was the current state I was in. And we have our case process. Remember, where did that come from? Here was our process. Okay? So if I'm in the process state, if my card is valid, then I change my current state to be dispense. If the card was invalid, I would remain in process and keep going. Okay, so this is part 3. This is my transition logic. And then if you wanted to, you could have the output, which could be produce the cupcake.